In this lesson, we are going to investigate the equation of a line in slope-intercept form. We're going to start by looking at some tables of values and investigating a rule that gets us from x to y. If you'll notice in these tables, there is a constant rate of change. My y is increasing by 2 each time, while my x is increasing by 1. This constant rate of change is the multiplication factor in my rule. So if you double x, how do you get to y? Double x, I get 2, but I need one more to get to y. Oh, does that work for all my x's? Double it, yes. Double it, yes. So basically, I need to add 1 after I double my x. And that's how you get to y. And that's basically the rule, which in other words is the equation that represents how I get from x to y. If I were to plot these points, 0, 1, 1, 3, and 2, 5, you'll notice that they fall in a line. Well, whenever you have a constant rate of change, it's the slope of the line. Rise over run, up, over. And that's what creates a line. So this becomes a linear function. And so the slope is 2, my rate of change. And you'll also notice something about when I'm inputting 0 for x. When I input 0 for x, I get the y-intercept. So you'll notice that this number at the end will always be the y-intercept, the value of y when I input 0 for x. Let's take a look at the next one, and we'll go a little bit quicker here and see how it goes. This time, my output is decreasing by 3, while my input is increasing by 2. It's a constant rate of change, therefore it's linear. Therefore, my multiplication factor is -1/2. I don't even need to fiddle with my rule here. I could try it. But I know by adding 6 every time, because 0 is the easiest one to input, if I multiply my -3/2 by 0, I know I need 6 more to get me to 6. And we could test that out. Multiply 2 by -1.5, add 6. Multiply 4 by -1.5, add 6. Let's graph our points. 0, 6, 2, 3, and 4, 0. You'll notice yet again my y-intercept, be careful, your y-intercept is the point at which you are intersecting the y-axis, as compared to the x-intercept, which is the point you're intercepting the x-axis. You'll notice yet again this is a linear function in which my constant rate of change is my slope, 3/2, and my y-intercept is the 6. So we have just found a way to write the equation of a line, which is the rule to get you from the input to the output. This rule, or equation, is y equals mx plus b, in which m is the slope of the line, and b will always be the y-intercept of the line. So this would be b, and the slope of the line is m. Let's look at some examples. Now that we know that little shortcut, let's see if we can figure out the equations of these lines by simply looking at them. We now know the equation of a non-vertical line is y equals mx plus b. So we first have to identify b, which is 1, and count out our slope, which is, how do we figure that out? Oh, I need 2 clear points. It doesn't matter which 2 points I pick, because the rise over run between 2 points on the line is the rate of change. The ratio is the same no matter what 2 clear points I pick. 1, 2, 3/2. Oh, so now I know the equation of my line is 3/2x plus 1. My slope is positive because it's rising left to right. Let's try this one. b is 1, 2, 3, 4, negative 4. My slope is, there's another clear point, 4 over 2. Always reduce your slope to lowest terms. 4 over 2 is just 2. So we get negative 2x. Why did I write negative? The direction of my slope is falling left to right. Minus 4. All right, we could do the next one. What's b? Oh, b is 0. My output is 0 when I'm inputting 0. So that's my y-intercept. My slope is 1 over 1, or just 1. I could write it like this, 1x plus 0, but I don't need a multiplication factor of 1, so I just write x and I don't need to add 0. So y equals x is the equation of this line. If I didn't give you the graph and I just gave you the slope and a point, notice what this point is. This is the y-intercept, the value of y when x is 0. I can just plug in my slope and plug in my y-intercept, and there you go. A reminder, a rule is, an equation is a rule that every time you plug in x, you will get y. All points on the line satisfy this rule. Now I can also graph using this rule. Rather than making a table of values, plug in x, find y, plug in x, find y, we can just use our slope-intercept to help. For example, in A, my slope is 2, or 2 over 1 as a fraction. Rise over run. And my y-intercept is negative 3. So to graph, I simply plot my y-intercept on the graph, because that is 1 point on my line. And the property of slope 2 over 1 is the same property between all points on my line, and there we go. We can quickly graph without needing a table of values. So let's try the next one. In this case, m is negative 1. I always make my fraction a slope so I can count rise over run. And my b is positive 1. So we plot the y-intercept. Negative means to go down. If you have a negative slope, I always put the negative on top because it tells you to go down or up, and then write 1. You can always check because the direction of your line should be falling left to right for negative slope. Let's try C. I know my slope is 3, or as a fraction, 3 over 1. My b, however, I don't know, so it's 0. It's plus 0 at the end. So that's my y-intercept, is at the origin. So 3 over 1 means up 3, right 1. I do it a few times just to make sure my line is accurate. And there's infinite number of points on this line, so I extend it all the way through with arrows on either end. The last one is a special case. There is no x. There is no x. In other words, my constant rate of change is 0. There is no change. So if there's no change, it's a constant function. Y is always 7. So where's y7? y7 is here, but y7 for all values of x. So it becomes a horizontal line. This is where y equals 7. The slope is 0. There is no rate of change. What happens if we want to graph these functions, linear functions, and I don't know the slope and y-intercept because they are not in slope-intercept form? What do? Well, I have to just convert them first. You isolate y. You get y by itself. The 3x becomes negative 3x because it crosses over, and the 6 stays positive. This is now a slope of negative 3 and a y-intercept of 6, which you could graph. Let's try this one. Always take the sign in front of the term. It stays with it. The 4x becomes negative 4x plus 6. But I don't have 1y, so I have to divide out the 3 to each and every term. Negative 4x over 3 could also be written as negative 4 over 3x. Those are the same thing. And so now I know my slope is negative 4 over 3 and my y-intercept is 2. One last one. What happens when your y has a negative in front of it? Well, that's okay. We're going to do everything the same. And we're going to divide out a negative 6 to each term. You'll notice whenever a term crosses the equal sign, it will switch signs. And so I get, be careful, a negative divided by a negative becomes a positive, and 2 over 6 can be reduced. And a positive divided by a negative is a negative. And now I could easily graph by plotting negative 1 on my y-intercept and counting rise 1, run 3. Sometimes your rule will have a missing parameter. In this case, b is missing. I know I have to double x, but what do I do? What do I add to get to 1? Well, we could just think it through. Double x, I get 4. Well, I have to subtract 3 to get to 1. But it doesn't always work out to nice numbers like that. So let's work on a little bit of a strategy so when the numbers aren't always nice. Well, remember, a point on a line is an example of an input-output that works for this line. So I'm going to input the y here as my output. I'm going to put the x in place of my x. So I'm going to place my input-output example in and figure out what b, oops, I should have written that as a plus sign, makes this rule true. 1 minus 4 becomes negative 3. Oh yeah, b is minus 3. I would do the same thing here, but what is the x-intercept of negative 2? Whenever you have an x-intercept, it's the value of x when y is 0. You would plug 0 in place of y, negative 2 in place of x, and find b. Sometimes I could be missing a different parameter. Sometimes I don't know what to multiply by, then subtract 2. A little bit harder to guess and check, but you could do it if you wanted to. If I want to subtract 2, that means I want to get to 4 when I multiply. Oh, if I multiply by negative 2, I'll get to 4, and then I could subtract 2. But again, let's try a little bit more systematic approach. Let's use our possible input and output to figure out m. Plug in 2 for y, plug in negative 2 for x, and solve for m. Whenever you have a variable multiplied by a negative, I reverse the order because that's what we like for algebra. Now I want to get this by itself, so I add 2 to both sides. That's why when it moves to the other side, it changes signs. Now I divide by the number in front of m. And last but not least, I have what I knew all along. M is negative 2. That is the missing part of my rule.